Good morning, all, to the lecture number 10 of solid mechanics. We are going to solve some numericals based on the previous lecture's knowledge, that is SFD and BMD. We are going to solve some numericals in this lecture number 10. I am Professor Sachin Todkar. And at the end of this lecture, we all should be able to understand the problem solving of shear force and bending moment diagram, because we have seen the sign conventions. That sign conventions we have to use properly to solve the numericals. Now, for online examination, there will be 2 marks questions, but in that 2 marks questions also, you need to solve some numericals based on your uh, sign conventions of shear force and bending moment diagram. Also, for chapter number 3, that is bendings and shear stresses, we need to calculate bending moment and shear force. So chapter number 3 also important uh, for this shear force and bending moment diagram. And in chapter number 6 also, for principal stresses, we need to calculate shear force and bending and moment diagrams. So we'll solve one basic numerical, simple numerical, in which all point loads are there, and this is simply supported beam with 5 Newton, 10 Newton, and 8 Newton forces at 2 meter, 4 meter, and 7 meters distance. So we'll solve this. It's very simple. First thing first is we have to calculate the reactions at point A and point B. And for that, what we need? We need the equilibrium equations. I have taken some numericals in class also. So those who have attended classes, they will get to know. First thing is to calculate equilibrium, the reactions with equilibrium equation. And equilibrium equations are very simple. These are summation of all the forces in y direction must be equal to 0. Summation of all the moments at any point must be equal to 0 to be to keep the beam in equilibrium position. So these two equations we need to calculate for the reactions. Now there will be reaction at point A. Yes, there will be reaction at point A. That will be a vertical reaction because all the forces are in vertical direction, and reaction at B we have to calculate. So from that we can start our example. So this reaction at A and reaction at B will come into picture. Now we have considered that using condition of equilibrium, summation of all the moments in at any point A must be equal to 0 and all the clockwise moments positive. So if I'm going to take the moment at this particular point, then all clockwise moments are positive. So these all 3 moments will be positive. 5 Newton, 10 Newton, 8 Newton, and this will be negative. So it has been taken minus RB into 8, minus RB into 8 plus 8 multiplied by the distance of 7 plus 10 multiplied by distance of 4 and 5 multiplied by distance of 2. And if I'll solve this numerical, I'll get the value of RB is equal to 13.25 Newton. You can calculate on your own and you will get the answer, same answer. So using the condition of second condition of equilibrium, that is summation of all the forces in y direction must be equal to 0. We will get RA plus 13.25 must be equal to 5 plus 10 plus 8, and it will give 9.75 Newton. This is the basic part of your SFD BMD diagrams to calculate the reactions. So we have calculated reactions. One reaction came 9.75. So this is 9.75. Newton. All the units are in Newton, so your force will be also in Newton. RB is 13.25. Now, in second diagram, you will see there are sections we have taken. These sections are very important because we have to calculate the shear force before that section and after that section. So it will be helpful to calculate the shear force and bending moment diagram easily. So shear force at section AA is denoted by VAA and so on. So you will see at the section 0 there will be no force. At section 1 we have taken the sign convention as left upward positive. So if at section 1 if I'll see, it will be plus 9.75 Newton because it is an upward direction. So I have taken it as positive shear force. Now section 2 up to section 2 there is no any force. So it will be again 9.75. At section 3 it will be 9.75 minus 5 because this is downward. So left downward is negative, upward positive, downward negative on left side, that we are going to remember. LUP and LDN will be your sign conventions. So it is 9.75 minus 5, it is 4.75 newtons. Okay, up to section 4 there is no force, so it will remain as it is 4.75 Newton. At the point section 5 you will get 4.75 minus 10 because it is left downward, so left downward is again negative and it will give 4.75 minus 10, 5.75 and so on. These are all calculations. These calculations are very easy because the numerical is easy. Now you'll get to know at up to section 6 there is no chance. At section 7 again left downward negative, so 5 point minus 5 point, sorry, here is sign convention missing, minus 5.25 minus 8, it is equal to minus 13.25 Newton. And at the section 9 you will get minus 13.25 plus 13.25 because this RB is upward positive and it will become 0. When your first and last point becomes 0 in simply supported beam, it is your check that you have to remember, because shear force starts from 0 point and ends at 0 point, that you have to remember. Now we'll see the diagram, how we are going to draw that diagram. The diagram will be very easy. 9.75 upward up to this C point, there is no any other force, so 9.75, then 4.75, then up to this point D there will be 4.75, then it is downward minus 5.25, here it is minus 13.25 and it will become 0. Now we have to remember one thing. I would explain in your classroom, that is all the calculations of shear force and bending moment should be on left side of your page and your diagram should be on right side, or vice versa. But you have to remember that you have to use 2 pages in case of your offline examination. Now your examination is online, so there will be no need of these type of things, but you have to remember again the things when you are going to solve the numericals for your own in calculations you are going to do. Your calculation and diagram should be on the same page, then only your answers will be correct and there will be no confusion. Because in solid mechanics or strength of material, the problem is with calculations only. The students have made mistakes in calculations only, and that's why they fail in the examination. So you have to practice the calculations day by day. So this is a shear force diagram only. Then we'll see bending moment calculations. Now bending moment calculations, we have to remember bending moment of simply supported end is always zero. So moment at A as well as moment at E will be equal to zero. Now in between, sorry, E, moment at B, the last point is B. So moment at B is equal to zero. Now how to calculate the bending moment? We'll go again towards the diagram. So I have to calculate the bending moment at this point. I have to remember that I have to take bending moment on either side of this point. Now in this case, it is simple to calculate the bending moment on this side, or that is left side of that particular beam. So if I want to calculate moment at point C, what I'll do, 9.75 multiplied by 2. So it is around 19.5. But what is the sign convention? You will see this force is in upward direction, and that's why this beam will show us a sagging kind of diagram. A sagging kind of diagram we are going to see. So that's why your moment will be positive. There will be sagging. That's why it is written 9.75 into 2, that is 19.5 Newton meter. Now in second case, 9.75 into 4 minus 5 into 2, because the force was in downward direction, so it will cause hogging. So this part will cause sagging. That's why it is positive, and this is causing hogging moment or hogging, you can say curvature. That's why it is minus 5 into 2, and it is equal to 29 Newton meter. Similarly, again, this is sagging, 9.75 into 7, 5 into 5 is hogging, and 10 into 3 is hogging. This is very important to, you can say, understand what is sagging and what is hogging. You will see here it is sagging. Due to this force, it is sagging. Due to this force, there will be hogging. Due to this force, 10 kilonewton, sorry, 10 Newton, it will be again hogging. So sagging and hogging, how you are going to consider? If you have any, you can say a steel rule or a plastic rule, then you have to find out. I'm just using this pen. If you, okay, if it is visible properly, then if there are forces in upward direction, then what will happen? I'm keeping this pen fixed in my second hand, this left hand, and with right hand, if I'm doing the sagging bending moment, then it will be, sorry, the upward bending moment, then it will be having sagging curvature. Also, if I am giving a downward force, then it will hog the particular beam, that we have to remember. So these are only the sign conventions to be remembered in this, you can say, type of examples. And then your SFD BMD is very easy. Yeah, you got the values 19.5, 29 and 13.25. This was the simple case. So your bending moment was completely on upper side or positive side. This is the combination of shear force and bending moment diagram. You will see 9.75, 9.75, 4.75, 5.25, 13.25 and 0. This is SFD. and this is BMD 19.5, 29.5, 29 and 13.25 Newton meter. Keep the this unit in your mind, because for shear force it is Newton and for bending moment it is Newton meter that you have to remember. Now we'll see the second example. In this case, point as well as UDL is given, and this beam is overhang on both sides. You will see A and B points are in between, and there is C and E point which is having overhanging load. In this case, if there is any point of contraflexure, then we have to calculate that point of contraflexure. So again, first step first, that is we have to calculate the reactions at point A and B, and for that we need to calculate the basic thing, that is we have to use equilibrium equations. Now in this case, I have shown the reaction at A and reaction at B with blue arrows, and you will see for calculating reactions, okay, here is one trick, that is due to symmetry of the beam, loading must be same on both sides or on RA and RB that we have taken, and with the help of that you can directly calculate what is the reaction with the help of all the forces. So this is 5 kilonewton, this is 10, this is 5, so total 20 kilonewton on upper side as a point load, and 2 kilonewton per meter on the span of 6 meters. So it is equal to 12. So it has been written here, 5 plus 10 plus 5 plus 2 into 6, and if I'll divide it by 2, if I'll divide it by 2, then I'll get 16 kilonewton force. So this is one kind of trick, but if you will use a regular formula, regular equilibrium equations, you will get the same answer, 16 kilonewton. This is your homework, try to do at your own, that is if your reactions are coming to be 16 kilonewton or not. Now shear force calculation, again I have taken this sections at each and every point load. Then what will get shear force at 0 0 or before 0 0, it will be 0. Shear force at 1 1, left downward is negative LDN, so it is equal to LDN, left downward negative, so it is minus 5.5 kilonewton, up to 0.22 or section 22, that is minus 5 kilonewton. At 0.33, left upward positive, so it will 16 kilonewton will come into picture, minus 5 plus 16, 11 kilonewton. At section 4.4, now at section 4.4 we have to remember that a one UDL is there as well as a point load is also acting. So before and after is very important in this case. So before this 10 kilonewton, what will happen? This 5, 10 and this UDL or part of UDL, that is 3 kilonewton. So it is equal to minus 5 plus 16 minus 2 into 3. As intensity of loading is 2 kilonewton and the span is 3 meters. So 2 into 3 and it will become 5 kilonewton. Now again, if I'll see at section 5.5, this 10 kilonewton force is additional and it is left downward. So 5 minus 10, it is equal to minus 5 kilonewton. Okay. Similarly, at section 6.6, -5 minus this much, that is 2 into 3, so -6, it is -11 kilonewton. At section 7.7, again this left upward positive force will come into picture, so -11 plus 16, it will become 5 kilonewton. And up to 8.8, there is no force, so 5 kilonewton. And after this force, 5 minus 5, it will become 0. So your first and last must be 0. Shear force calculation will be checked with the help of this. If first and last point is 0, then your calculations is completely correct. Now again, for bending moment calculations, what we are going to consider. For bending moment calculations, you will get to know this is downward and this is support. So it will be hogging bending moment. Now, due to this force, it will be sagging. Due to this UDL, it will be UDL. We consider it as, sorry, for UDL, we consider it is acting at the center. So according to your point of interest, you will get to know it is sagging or hogging. It will create hogging. Again, this is hogging, this is hogging, this is sagging, and this is hogging. That we have to remember. This is your SFD. With the help of your calculations, you can calculate 5 kilonewton. Sorry, you can draw the diagram 5, 5, 11, 5, -5, -11, +5, +5, 0. So this is your shear force diagram. It's easy. Now bending moment diagram. This we have to remember. Bending moment at free ends is always 0. So bending moments of these particular overhang beam MC and ME is 0. We have to calculate only this, and this bending moment. So 3 bending moments we have to calculate. This point, you'll get to know that for this point from left side, if we'll calculate, it will be easy. For this point, if I'll calculate it from right side, it will be easy. So it will be easy. And for this point, you can calculate from either side, whichever is suitable. So moment at A and moment at B, you will get to know it is 5 into 2. Why it is minus? I have just explained you, because it is a hogging bending moment. Five into 2, it is hogging, so it is minus 10 kilonewton. For B also same, 5 into 2, and it is hogging, so it is negative. Now point D is very important. For point D, I can start from either side, from left side or right side. You'll see 5 kilonewton into distance of 5, and it is hogging, so it is minus 5 into 5. 16 into 3, it is sagging, so it is positive. Minus 2 into 3 into 1.5. This is very important. Now, how it comes, that we are going to see. This is loading of 2 kilonewton per meter. 2 kilonewton per meter. It is at distance of 3 meters multiplied by 3. So you will get the actual loading 2 into 3. And we suppose it is acting at the center of the span. The span is 3 meters. The span is 3 meters. So the center of span is 3 divided by 2, which is 1.5. And that's why this calculation comes as 2 into 3 into 1.5. Okay. And that's why your answer comes 14 kilonewton meter. Your answer comes 14 kilonewton meter. And this bending moment diagram will be like this. Here there is no point of contraflexion. Oh, sorry. There is point of contraflexion. Shown it wrongly. This is 14 kilonewton meter, so it is positive, so it will be an upward direction. So there will be 2 points of contraflexion. And how to calculate the point of contraflexion, that we are going to see here. We are going to find out these point of contraflexures xx with the help of this equation. Mxx is equal to minus 5 into bracket 2 into x. We are going to consider this distance as x. So minus 5 into 2 plus x plus 16 into x. This force was 16 multiplied by x minus 2 into x square by 2. So we are going to multiply it 2 into x. Here 2. There is some problem with this. 2 into x into x divided by 2. Just now I have explained how to calculate the okay. So get it as 2 into x divided by 2. That will come into picture, and it is equal to 0. And if we can solve this numerical with the help of calculator, there is one mode in calculator. Right now I don't have the calculator, but I have explained in a classroom. I'll again explain it. In your calculator, go to the mode button. Mode button, you have to press 2 or 3 times. Then it will come equation mode. And equation mode, we have to consider second degree equation. Second degree equation, we have to put the values of ax square plus bx plus c is equal to 0. In that case, we have to put the values of a, b, and c, and you will directly get the two answers. One is 1 meter and another is 10 meters. So try to do this calculation on calculators because this is very important. This calculation part is very important in your examination part, because you have to answer this within 3 to 5 minutes. So you have to practice a lot. If you are not knowing that equation mode, then I'll explain again in next lecture, because right now I'm running out of time. But you have to do it on your own as a homework today. Tomorrow I will make available the calculator and I'll show you the calculations again. So it's very important to calculate the square roots of quadratic equation, and it is very easy actually, but you have to do the practice and you will get the point of lecture as 1 meter or 10 meter. Now you will see the total span is 2 plus 3 plus 3 plus 2. So total span is 10 meters. So 10 is not the answer. 1 meter is correct answer. So x will be 1 meter from this side and from this side also. So these are the point of control lectures. Okay. Till the time, maybe if there is any question, please unmute yourself and ask me the questions related to anything. because maybe some students were asking about the examination, some students were asking about the submission. Everything you can ask right now.
Hello, sir.
Yes, ask.
When is your our oral, sir? Viva.
Orals schedule is not declared yet, but as soon as this it will be declared, we'll make it public in your group. So no problem at all, Vivek.
Okay, sir.
Just keep your submissions ready. I know orals will be online only, but still your questions will be from submission only. Okay. Any
Okay,
other
sir.
question?
Sir, is the orals are confirmly held or not?
Last year we have taken all the orals online, so this year also we can't predict the situations. No, right now the cases are increasing, so online schedule will be there. I'm just this possibility of 99% that is online oral will be there. External will come and online, and he will ask the questions. So your submission, if your submission has been written, you can give the answers from that submission part. Any other question? Okay, somebody. Pradeep. Pradeep, tell me about your scholarship form. So on this note, we'll meet again in next lecture. Till then, thank you very much for attending the lecture, and I'll just conclude the meeting. Thank you.